Which NBA teams have had the best improvement from their previous season? Which teams have had the best 5-year run? And which teams have the best win and loss records in the league? We're going to use the NBA dataset and some SQL to find answers to these questions and more. We will use this dataset here called NBA Database on the Kaggle.com website. You can find a link to this dataset in the description. To download it, click the big download button on the page here. You'll need to be signed in to the Kaggle website first, so create an account and sign in if you haven't already. Save the file somewhere on your computer. This is a zip file, so we'll have to extract it before we can import it. So extract it on your computer. We now have a folder with many CSV files here. Let's import them. For this video, we'll use an Oracle database with Oracle SQL Developer, but you can use whatever combination of database and editor that you like. We're going to import all of the CSV files into our database. I've got videos on how to do this in other editors and databases, which I've linked in the description. To import a file, expand your connection, right-click on Tables and select Import Data. The Data Import wizard is shown. Ensure Local File is selected here. Then click on the Browse button and navigate to the folder where the CSV files were just extracted. Select a file and click Open. The file name is shown in the file box here. You can adjust some of the settings here for delimiters and header size. For me, the default settings worked for all of these files, so I'll click Next. We will see step 2, which is the import method. You can leave the default value of insert selected here. Enter a table name, which will be created by this import process. I'll enter the same name as the file, which is Common Player Info. Click Next. On the Choose Columns page, we want all the columns inserted, which is the default, so we can click Next. On the column definition page, we can see the details of each of the new columns that will be created, such as the data type and length. This is an area that is most likely to cause issues. The import process will estimate the length of the data, but it may be wrong. I'll add in some points in the description for the files and columns where I had to edit the default length, so you may need to do the same. Click Next. We'll see the last step, which is the import summary. Click Finish. The wizard will close and the file import will start shortly. After a couple of seconds, this message should appear saying it was successful. Click OK. We've now imported one of the files. We'll need to repeat the process with the rest of the files, so I'll skip ahead to the point after I've done that. We can see several tables here, one for each imported file. Our data is now imported. Let's run some simple queries on these tables to see what's inside. We'll start with some simple select star queries. First, we'll look at the player table. We can see a list of NBA players here with IDs, names, and whether they are active or not. What about teams? We can write and run this query and see a list of teams in the NBA. It has 30 teams, so this is just a list of active teams. Let's look at games. We can query the game table. This shows a lot of information and each record represents a game that has been played. We have things like the home team name, the game date, and a game ID. We have this WL home column, which I've looked up and discovered that it represents whether or not the home team has won. If they have, it's a W, and if not, it's an L. We see a lot of other stats about the home team, such as FGM, which is field goals made, the FTPCT, which is free throw percent. Then we get to similar columns for the away team. Finally, we have a column called season type, which represents the type of game it's for. For these rows, it says regular season. So there's a lot of data here. Let's look into our first question. The first question we want to answer is, how many games has each team won and lost in their entire history? Let's look at our data. We saw the game table earlier, which had a record of games played, teams, and who won each game. Let's write a query to get the teams in each game, the WL home column and the WL away column. I'll also add the game date so I can look up the official results to see if it's right. We run this and see the game date, teams, and the win-loss fields. We can see that the WL home and the WL away columns are opposites of each other, which is what I expected. If the WL home is W, then the WL away is L, and vice versa. Let's check one of the games in this list against the NBA website. I'll find a recent game by ordering the results by the most recent games at the top. We can see the most recent game is between Denver and Miami on the 12th of June 2023. According to this table, Denver won because they are shown in the team name column and the WL home column says W. Let's look this up. I can Google Denver Miami NBA 12th of June 2023 and see the result from Google says Denver won. It was the last game of the NBA Finals. Just to be sure, I can click on the NBA link here and it shows the same thing. So how can we use this to calculate the number of wins for each team? Well, we can find the team name and then count the number of records where the WL home column is W. We add a group by and our query is ready. We can run this query and see our results here. However, we are only getting teams and data for the home team. This only shows the number of wins a team has if it played at home. We need to include the away games as well. So we need a second query to do the same thing but on the away columns. We can combine them into a single result using the union all keyword. Let's also order by the team name. We see our results here. We get 2 records for most teams. This is because one row represents the home wins and the other is the away wins. How can we combine them into a single row? We can perform another aggregation, sum this wins column and group by the team name. We could do that, but then we would have a list of teams and the number of wins. We want to see the losses as well. We are filtering on records where the related WL column is a W. How can we get the losses? Let's try a different approach. We can use the case statement on these WL columns to determine if a team has had a win or a loss. We'll do this for the home team first. We add the team name and then start a case statement. We want to be able to do a sum on the number of wins, so we want to return a value of 1 if the team has won and a value of 0 for a loss. Our case statement looks like this. Then, to calculate losses, we do something similar. We check if the value is L and return 1 if it is, and call the column losses. Let's run this query. We can see a list of teams and a 1 in either the wins or losses columns. Each row represents one game. Now we can aggregate the data. We can do this by surrounding the case with sum and then adding a group by. We don't need to filter on records where the WL column is W because we want all records. We run this query and see our results. We can see each team again and we also see the number of wins and losses. This is progress. This result shows only the games for home teams because we are checking the home team column. Like the earlier query, we need to add the away teams. So we can update our query like we did earlier to add a union all, then the away team concept. The query is similar. We run this and see the results. We see 2 rows for most teams, which represent their home wins and away wins. I think we're almost there. The next step is to aggregate this data so we can group by the team name. We can surround this query as a subquery, then select the team name, the sum of wins and the sum of losses. We'll order by the team name to check that we only have 1 for each team. The results are shown here. There is 1 record for each team, with the total number of wins and losses. Let's order this by the number of wins in descending order. We run this and see the results. This is what we wanted. We can see that the team with the most number of wins all time is the Boston Celtics, with 3,625. Then we have the LA Lakers, then the New York Knicks. Who has the worst? We can scroll to the bottom and see a bunch of teams with 0 wins and 1 loss, or 2 losses, or a few. These look like international teams, who have perhaps played in an exhibition or a preseason game. Let's scroll up a little until we find an NBA team. Here we go. We can see the Pittsburgh Ironmen with a record of 15 wins and 45 losses. According to Wikipedia, they were a member for a single season in 1946, and their record matches what we saw. Interesting. Well, that's the first question answered, and the team with the most wins in history is the Boston Celtics. If you want to get all of the SQL queries mentioned in this video and an entity relationship diagram for the database, get your free guide to this project by checking out the link in the description. Question 2. What is the best win-loss record by a team in a single season? If you're familiar with the NBA at all, you probably know who this is, or could guess. But let's look at the data and find out. In our earlier query, we found the win and loss records for each team for all time. We can modify this to show the record for each season. There's a column called Season ID that we can add to our query. There's also Season Type, so let's add that. We add it to the subquery for both the home and away teams and then the outer query. We run the query and see the results. The Season ID is a 5-digit number. Then we have the Season Type, which is regular season or playoffs, and there are a couple of other values. We then have the team name and their wins and losses. We're getting close. This Season ID is actually a combination of two things. The first digit represents the season type, which is 2 for regular season, 4 for playoffs. Then the next 4 digits are the year of the season. NBA seasons start in October and end around June the following year, so it actually covers 2 years. This year in the Season ID refers to the start of the season. So let's extract the year from this Season ID field. I'll do this on the inner query to both of these places so I can select the cleaner version in the outer query and then group by it. We run the query and see the results here. The season is easier to read. Now we only want to see rows for the regular season, so let's add this to our where clause. We run this and only see regular season games. Now because all values in this column are the same, we don't need to see it, so let's remove it from our select clause. We see our results here, which shows the year, team name, and their wins and losses. We're getting close. We've got a subquery here in our query. One thing we can do to make this neater is to use a CTE. Let's do that now. We run this and the results are the same, which is what we expect. Now, when a win-loss record is calculated in the NBA, it goes by something called a win-loss percentage, which is a number that represents the percentage of wins from all games. This allows for a more even comparison between teams who may have played more games than others. We can calculate this and use it for our sorting. To add this, we get the sum of wins and divide it by the sum of wins plus losses. We'll call it win PCT. We run this and see our new column here. It's a long decimal number that I think is a bit hard to read. So let's surround this with a round function and round it to 3 places, as that's what we normally see in NBA standings. We run this and see our results here. Finally, let's order by this win percent column in descending order and see the best records. And here we go, here are our results. In number 1 position are the 2015 Golden State Warriors with a record of 73 wins and 9 losses, which is the best record of all time. In number 2 is the 1995 Chicago Bulls, which was the best record up until 2015. The next few spots are held by the Lakers, Bulls and Celtics. So that's question 2 answered. Question 3, who has the worst win-loss record by a team in a single season? We can find this by reversing the order by clause in our earlier query. We change this from descending to ascending and run the query. The top result here is the 2011 Charlotte Bobcats with 7 wins and 59 losses. I didn't know that. Let's look that up to see what the internet says. Wikipedia has a handy collection of pages for each team's record for each year, which I'll refer to for a quick summary of seasons in this video. If you search for 2011 Charlotte Bobcats, near the top you'll get a Wikipedia page for this. Click on this page. We can see on the right the record says 759, which is what we had. I wasn't sure because the Charlotte NBA team has had some movement in the last 20 years or so, and perhaps this season was split into 2 records in this dataset. What we can also see here is a summary of the season. Here it says, considered to be the worst NBA team of all time. Set the record for the worst winning percentage in a season with a .106 winning percentage. And further down it says, clinched the worst record in NBA history. So I think our results were correct. Sorry, Charlotte fans. We can see the next few records are for Philadelphia, then for a team called the Providence Steamrollers, then the Denver Nuggets. So we've answered question number 3. If you want to get all of the SQL queries mentioned in this video and an entity relationship diagram for the database, get your free guide to this project by checking out the link in the description. Question 4 is which team has had the best 5-season span, or said another way, which team has the best win-loss record over a 5-year period. We've seen some good single-season records earlier in this video, and if you're familiar with the NBA, you probably know of a few eras of teams doing well. But let's see what the data says. Here's our query from earlier in the video, which showed the best records for a season. We can run this and see our results here. We want to see the best 5-year record for a team. To do this, we should start by ordering our data in a different way so we can understand what we want to see. I'll order this by the team name, then the season. So what do we want to show? For each row here, we want to see how many wins they have over the past 5 years, including this year. We also want to see the number of losses over the past 5 years, and then calculate the win percentage. This will let us see the best 5-year record. Let's start with the wins. How do we do this? We can use a window function. Window functions are a very handy feature in SQL, and they work in many other vendors, not just Oracle. We want to use the sum function because we are adding values. We could add a new column here, but we need to sum this other column which is already a sum. This query is also calculating the win percentage on the sum value, so I think this is a good time to enhance our CTE to include the sum values. Let's try this. We move this part of the query into the CTE and the group by. Then in the outer query, we just use the column names and no sum or group by. We run this query and it shows us the same data. Now we can more easily use a window function. We add a new column which is a sum of the wins. Then we add the over keyword. Within this, we want to partition by the team name because we want to calculate the sum function separately for each sum. Then we order by the season because we want to calculate data based on the recent seasons. We give this an alias, then run the query. We see the results here. The new column shows the number of wins, which increases with each row. However, it just keeps going up. It's actually calculating a running total for all seasons so far, not the last 5 years. How can we fix this? We can update our function to only consider the last 5 rows. To do this, we add something called a frame clause to our window function. After the order by here, we add rows between 4 preceding and current row. This means the function will only consider the current row and the 4 previous rows, which is a 5-year period. We run it and see our results here. It looks pretty good. We can see some rows further down no longer keep going up, and they match the sum of this row and the last 4 rows. Let's do the same thing for the losses. We add a new column, then run the query. We can see the losses for each team over the last 5 years. Now we can calculate the win percentage and then order by that to see the best records. To calculate the win percentage, we operate on these wins 5-year and losses 5-year columns, but they are being calculated here with this window function. To clean this up, we can add another CTE. This will make it easier to calculate the win percentage as well. So we add a second CTE here, which can refer to this first CTE. Then we select the columns and add in a new win percent 5-year column to show the win percentage for 5 years. We run this and see the results, which is what we wanted. Finally, let's order by this column to show the best records at the top. We run the query. We can see a list of teams, seasons, and their win percentage over the last 5 years. In the first spot, we see the 1946 Washington Capitals with a 5-year win percentage of 0.817. That wasn't what I expected. If we look closely, the 5-year record matches the 1-year record. This has happened because this was the first season for this team and there are no rows before it, so the 5-year record only includes 1 year. We should exclude rows like this, but how? We can use a function to calculate the number of rows included in the window, which should return from 1 to 5. Then only show rows where this number is 5. We do this by adding a count function and using the over clause. This over clause will match the others, and we'll call it seasons included. We'll add it to the select clause so we can see it to check it's okay, before filtering on it. Let's run the query. This is good. We see the first 2 rows have 1 season of data, which means the 5-year values match the 1-year value. The next few rows have a value of 5, which are the records we want. So let's filter on this column and show only rows where the seasons included is 5. We run this and see the results. It shows the top row is the 2018 Golden State Warriors, who over the last 5 seasons have 322 wins, 88 losses with a percentage of 0.785. Let's check this data. We can update our query to filter on the Golden State Warriors, and not filter on this season's included for now. We run this and see our results. We can scroll down and see they had a pretty good run leading up to 2018. The wins and losses for 5 years line up, and the win percentage matches. That's good. Let's run our earlier query to check the top results. We can see the 2018 Warriors at the top, then the 2017 Warriors, then the 1985 Celtics, then some Lakers and Celtics seasons, then the Spurs in 2015. So that's pretty interesting. And question 4 is answered. Question number 5 is, which team has had the biggest increase or decrease in wins from one season to the next? We want to find teams that have had a quick turnaround from one season to another or a sharp decline. Let's start with a query that looks similar to a previous query, which finds the seasons and wins and losses. We run this and see our results. To find the seasons where a team has had a big change in their wins, first we need to find the wins from the previous season. Then we can compare this to the current season. In SQL, to find the value from a previous row, we can use the lag function. So let's do that. We add the lag function and use the over clause in the same way as other examples to find the previous row for the team based on the season. We run this and see our results. A new column is shown and we can check a few of the values and see they match the previous row's wins value. If a value is null, it means there is no record for the previous season. Now we can compare this value to the wins value to see the difference. To do this operation, we would need to copy this calculation. And whenever we do that, we introduce a risk of messing something up because the calculation is repeated. So let's enclose this in a CTE and refer to the calculated column. While we are here, we can probably remove the losses and win percent columns, as we don't need them for this query. We run this and see a similar result as earlier. Now we can easily calculate the difference. We add a new column and run the query. We can see the results here which look good. One example is this 1973 Atlanta Hawks team, which went from 46 wins in the previous season to 35 wins in this season, which is a -11 difference. Now let's order by this wins increase column. We run this and see these results. We have a bunch of rows that have null values for the wins increase, because the wins from the previous season is null. Let's exclude these rows. We run this and see our results. This looks better. The top row is the 2007 Boston Celtics, who went from 24 wins in the previous season to 66 wins in this season, an increase of 42 wins. Let's check this using Wikipedia. It's not official, I know, but it's a good way to easily see the records and a summary. The page for 2007 shows a record of 66 wins, which matches our data. We can click on this previous link here to see the previous season, which shows 24 wins. This also matches. Let's go back to the 2007 season to see if we can understand why the sudden increase happened. I think this is it. It says, off-season blockbuster acquisitions of Kevin Garnett and Ray Allen to join Paul Pierce, and then the best single-season turnaround in NBA history. So that explains it. If you're an NBA fan, you'll know who these people are, and that explains the big turnaround. What was the next record? The 2007 New Orleans Hornets from 18 wins to 56 wins. Interesting, not what I was expecting. Let's check their record. In 2007 they had 56 wins, which matches our data. In the previous season they had 39 wins. That doesn't match our data. We saw they had 18 wins. What's happening in our data? Let's filter on the New Orleans Hornets team and order by the season and run the query. We've got a few rows here for this team. In 2007 they have 56 wins, but the previous row shows 18 wins and is from 2004. We don't have data for the 2005 season or the 2006 season for this team. Interesting. So the calculation was correct, but it's the underlying data that has issues. What can we do? We can't add criteria to the lag function to check if a value is one number previous. It only works on rows. One thing we can do is get a list of all years and show the years, then show null values if we don't have data for that year. That could mean we have rows for 2005 and 2006, but they would be null and our previous year wins would not refer to the wrong year. Let's try that. First, what are the earliest and latest years in our data? We write this query that uses the min and max on the substring of the season ID field. We run this and see that the min year is 1946 and the max year is 2022. So we need to list these years. A simple way to do this is to use a recursive query in Oracle to generate a list of numbers. We can use the connect by level keywords to do this, and there are other ways to do this in other databases. Here's an example. We can select the level column from dual and then say connect by level, then less than or equal to 10. We run this and see 10 rows with numbers from 1 to 10. We actually want a list of numbers from the earliest year of 1946 to the latest year of 2022. So we can adjust our query to add these numbers to it. We run this and see our results. We can see the first row is 1946 and the last row is 2022. This is what we want. Now we can use this result set and left join into our main query to show all years. Let's try that. We'll try this for just our New Orleans team here to see if it shows the right results. We'll add it as another CTE and then add it to the main query as a left join. We'll add some table aliases and our query is ready. We run it and see our results. It looks the same. This is because we are filtering on this team name, which would be null for records that are not in the game table. Let's remove the filter and try again. We can see all teams here. We can see for Atlanta Hawks that there are some rows missing here for 1975 and 1976. So it seems this approach doesn't work. This is because we have a list of all years, but we don't have a list of all years and teams. We could enhance our CTE to somehow combine it with all teams, but I think there's a better way. Earlier we saw how to use the sum function on the previous 5 rows. Is there a way we can use this on just the previous 1 row? Yes, there is, and it allows us to check that the previous row is 1 value less than the current row. We can use either max, min, or sum to do this. We'll only be checking 1 row, so the exact function doesn't matter. Let's use sum. We'll go back to our earlier query that got data for the New Orleans Hornets. Inside our season with prev CTE, we can add another column that calculates the wins from the previous season in another way. We use the sum on the wins column. Then in the over clause, we use the same partition and order by. Next we add our frame clause and we'll use the keyword range. We say range between 1 preceding and 1 preceding. This means we look for rows where the value is between 1 value less and 1 value less than the current row, or where the value is 1 less than the current row. The range keyword looks at exact values, and the rows keyword we used earlier looks at the row. This should show us the wins value from the previous year, and either 0 or null if there is no previous year. Let's run this. We get an error which says invalid data type. This has happened because our range keyword is doing a calculation and there's an issue with the data types. The calculation is being done on the season column, which is from this order by clause here. This season column is defined in the earlier CTE as a substring from the season ID. I think the issue is that the substring function returns a string, and the range keyword is using this as a string where it expects a number. Let's change this season to a number using toNumber to see if it helps. Here are our results. I think this looks better. In 2004, the previous year is 41, which is correct. In 2007, the previous year shows null, which is correct because there is no 2006 data. So ideally we would have data for 2006, but at least we've been able to avoid incorrectly calculating these wins. Let's update our query to use this as the win's previous value and use it in the difference calculation. These results look better. Now let's show all teams and order by the wins increase column. We've got a few rows here with null values because they don't have any previous season data. Let's exclude these. We run these and see the results. In first place we have the 2007 Boston Celtics, which we saw earlier was the right result. What about the next few rows? Are they correct? And why do they have sudden changes? In second place is the 1997 San Antonio Spurs, who went from 20 wins to 56 wins. This page shows they had 20 wins in 1996, and the next season they had 56 wins, which matches our data. It says here the Spurs selected Tim Duncan with first overall pick in the draft. It also mentioned on the previous page that David Robinson was injured, and in this season he has returned. So if you know the NBA, you know that Tim Duncan is a pretty good player, and so is David Robinson, so it's no surprise that the team did a lot better in this season. I'm a Spurs fan, so it's good to see them reflected in this list. In third place is the 1999 Lakers, going from 31 wins to 67 wins. The Wikipedia page doesn't mention any significant players being added, but mentions the Lakers hired former Bulls coach Phil Jackson, who is one of the best coaches of all time. So a combination of that and perhaps improvement from Kobe earlier in his career has helped. They also won the championship that year. In fourth place was the 1989 San Antonio Spurs. What happened that season? In this season they drafted David Robinson, the player mentioned earlier in the other San Antonio season. So this was another big draft pick which helped them immediately. Then in fifth place is the 2004 Phoenix Suns, going from 29 wins to 62 wins. In this season they acquired Steve Nash, who was a great player and seemed to have a big impact on the team. So it looks like our query is correct. We've been able to work out which teams have the biggest change in wins from one season to the next. And the main reasons for the increase are a big incoming trade or a draft pick or even a new head coach. What about the worst changes in a season? We can change the order of these results and run the query. We can see our results here. At the top is the 1998 Chicago Bulls, who went from 62 wins to 13 wins. This is a big drop-off. What happened? Well, it was the year of big change in Chicago. Phil Jackson, the head coach, resigned. Michael Jordan also retired. Scottie Pippen was traded and Dennis Rodman was traded. So a bunch of big names left the club and the result the following season reflected that. What about the next few results? The 2010 Cavaliers from 61 to 19 wins happened when LeBron James moved from Cleveland to Miami. The 2019 Golden State Warriors from 57 to 15 wins was when Kevin Durant left and both Steph Curry and Klay Thompson were injured. The 1996 Spurs are there because their best player David Robinson was injured. The 1998 Supersonics are also there because they had some injuries to the players that year. So it looks like the biggest impact to these teams dropping off is players being lost by trade or injury. That's not surprising, but it's good to know what these biggest changes are. Our question 5 is now answered. The biggest increase was the 2007 Boston Celtics, who added a few big names to their team, and the biggest decrease was the 1998 Chicago Bulls, who lost a lot of big names. This was only part of the analysis we could do on the NBA dataset. Stay tuned for the next video where I go into analysing player level statistics and see what interesting things we can find. Thanks for watching.